Let's take next numerical from your example, that is example number 2. So numerical is, see here we are taking one resistance, again one inductance, again at the second branch capacitor and resistor. Okay, this is the output, right? Here we consider the Vi of t, here we consider the Vo of t. See here resistor R1, this is R2, L and C. Okay, they are giving here only symbol, not a value. Okay, let's start again. As we know, there are three loops. So first loop we consider as a I1 of t, second loop we consider as a I2 of t, and third loop is again same I2 of t. Okay, let's start. Apply KVL at loop 1. Okay, see in the loop 1 there are two components, resistor R1 and inductor. So voltage across resistor R1 plus voltage across inductor equal to Vi of t. So what is the voltage across R1? R I1 of t, right? Plus what is the voltage across inductor? It is L d by dt of two current, because there are two currents. So the first current we use as I1 minus second current as a I2, right? Is equal to Vi of t. Okay, let's take Laplace here. So Laplace will become R I1 of s plus L, and Laplace of derivative is s, right? It is let's take multiplication here. So it is I1 of s minus SL I2 of s is equal to Vi of s. Okay. What is the common here? See, I1 is common here, right? So let's take I1 outside. For the inside, R plus R1. So this is R1, right? This is R1, right? R1 plus SL. Okay. Minus SL I2 of s as it is equal to Vi of s. Okay. We got as equation number 1. Let's apply KVL at loop 2. KVL at loop 2. When we apply KVL at loop 2, how many components are there? See, in the loop 2, three components are there: inductor L, capacitor C, and R2. Okay. Inductor L is equal to the voltage across inductor L plus voltage across capacitor plus voltage across resistance R2 equal to 0. What is the voltage across inductor? As we know, it is L d by dt, right? Again, there are two resistance, two current, that is I2 of t minus I1 of t, right? Minus Vc, so it is capacitor integration of I2 of t, right? dt, right? Plus voltage across resistance is a R I2 of t equal to 0. Okay. See, now can we take Laplace here? So Laplace means it is a S L I2 of t S L I1 of t minus 1 upon SC I2 of, one second, it is not t, it is a s, it is not t, it is a s, it is a s, right? Plus R I2 of s equal to 0, right? Is equal to 0. Okay. Now see, what is the common here? See, I2 is available here, I2 is available here, I2 is available here. Can we put I2 outside? What is the inside? It is the SL. One second, something is missing here. This is plus and right, so this should be plus. This should be plus, right? Plus 1 upon SC, right? Plus R, okay? And one term is remaining here, SL. I1 of S, this term is written here, is equal to 0. Okay, now once we shift this term at the RHS side, it becomes plus, right? So V is equal to SL I1 of S. See, S is multiply here. When we shift this side, it becomes divide. So I2 of S as it is, right? Once again, I forget something here. Maybe this is the R2, right? So this is the R2. This is the R2, right? And where is R1? R1 not here, right? So it becomes SL plus 1 upon SC plus R2, right? And it shift, it is like this, 1 upon S is equal to I1 of S. See, I1 of S is already available here. See, I1 of S, we get value of I1 of S, right? So it is equation number 2. Can we put this equation number 2 value of I1 of S into equation number 1? See, this is I1 of S, so can we put this value here as it is? We get the final equation. So let's put the value of I1 of S. Put I1 of S in equation 1. So it is I2 of S SL plus 1 upon SC plus R2, right? 1 upon SL, right? 1 upon SL into, what is the equation number 1? C. Okay, I1 here we put value of I1. Now R1 plus SL as it is. R1 plus SL as it is, and third term is SL out of S plus SL out of S is equal to VI of S. Okay, let's take common. See, this is the I2 available here, and again this is the I2 available here, right? Can we put I2 of S outside? For the inside, SL plus 1 upon SC plus R2. Okay, better to put circular bracket. Okay, then 1 upon SL as it is, again R1 plus SL plus SL, okay, is equal to VI of S. See, I2 of S we put as it is. Let's calculate this one. See, 1 upon SL is outside the bracket, just put inside. So 1 SL, when we shift in the inside, SL get cancelled, so it is 1 only. So it is 1 upon S square CL plus R2 upon SL, right? Okay, and in the second bracket, this is your first bracket, right? This is your first bracket, right? And towards the second bracket, see, in the second bracket, RSL plus SL, right? I think something is going wrong here. Plus, it is minus maybe. Minus SL, right? This is minus, okay? So let's put minus there. Okay, so this is minus, right? This is minus, okay? Because of this is minus, so SL get cancelled. See, SL get cancelled, so what is the remaining only R1, okay, is equal to VI of S. Let's multiply R1 in the bracket, so I2 of S in bracket R1 plus R1 upon H square CL plus R1 R2 divided by SL is equal to VI of S. Okay, let's apply KVL at the loop number 3. KVL at loop 3. Okay, for the loop 3, in the loop 3 there are two components. Let's see, loop 3 there are three components, two components, capacitor and R2, right? Let's apply KVL. Okay, so VC plus VI R2 is equal to V of t. What is the VC? It is 1 upon C integration of I2 of t plus R2 I2 of t is equal to V of t, right? What is the common? Let's take Laplace both sides. Okay, so it is 1 upon S C I2 of S plus R I2 of S is equal to V of S. Okay, what is the common here? I2 is common. Let's put I2 outside. What is the inside? 1 upon SC plus, this is the R2, right? R2, okay, is equal to V of S. Let's assume this is equation number 4 and this is the equation number 3. Let's divide equation number 4 and 3. Equation 4 divided by equation 3. What is equation number 4? This is the VO of S divided by V of S. This is your transfer function, right? What is the V of S? It is a I2 of S in bracket 1 upon SC plus R2, right? 4 divided by, what is equation number 3? Equation number 3 is I2 of SC R1 plus R1 upon S square CF. Okay. I2 of S bracket R1 plus R1 divided by S square CL plus R2 R1 SL. So this R1 R2 divided by SL. This is I. Okay. So this is the equation you get. Let's take new page. Okay, now see this I2 get cancelled, I2 get cancelled. What is the remaining? So this is called as a transfer function, right? Let's cross multiply here. So it will become 1 plus S R2 C divided by SC whole divided by again let's cross multiply this. Let's multiply with the SL. Let's multiply with the SL. So it become R1 L, right, plus S R1 L plus SL. Now we are multiplying with the SL, right? Okay, no, sorry. Here we are going to multiply with the S square CL. We are going to multiply with the S square CL, right? So when you multiply with the S square CL, so it become S square R1 CL plus S square, and both are cancelled here. C S square CL both are cancelled here, so only R1 is remaining plus C. What we are doing here? We are multiplying with the S square CL, right? Okay, so here S square CL, right, and here S square CL, right? So in the numerator and denominator we are going to multiply with the S square CL, S square CL, right? So S square CL in the numerator as it is, in the denominator it is going to cancel, and here S square CL, that means what is the remaining? 1 S is remaining here, right? LL get cancelled, so R1 R2 C is remaining here, right? C here again, okay, can we cancel out CS and 1S? C and C, so what is the remaining? C 1 plus S square R2 CL, right, divided by S square R1 CL plus R1 plus S R1 R2 C. So this is your final answer of given equation. This is your final answer of given equation. Okay, this is your final answer of given equation, right? Okay, let's compare with your given answer. It may be little bit difference, but according to calculation, see in SL they are giving common here SCR2. Okay, it is approximately equal. Okay, so this is your final answer. Let's move on the next example. Example number 3. Example number 3 is very much simple. Before watch this video, you just try yourself to solve the example. If you not able to try, not able to solve, then you see this video. Okay, example is very much simple. See, they are giving two resistance R1 and R2 and one capacitor C, right? This is input side, that is V of t. This is output side, that is V of t, right? Let's solve. Again, same. What is the first step? We are considering current from this loop. So we are considering I of t, and here again same current we are considering, that is I of t, right? Because there are single loop. Okay. Let's start. Apply KVL at loop 1. When we apply KVL at loop 1, what's happen? See, voltage drop across resistor plus voltage drop across capacitor plus voltage drop across resistor 2 is equal to VI of t, right? What is the voltage drop across resistor R1? That is I of t plus voltage drop across capacitor is 1 upon C integration of I of t dt, right? Plus voltage drop across resistor R2, that is R2, this is R1, right? R2 I of t is equal to V I of t. Okay, let's take Laplace here. Laplace transform at both sides. Okay, when we take Laplace transform, what's happened? This is R1 of R1 as it is. This is I of S, right? T become S, 1 upon C, and S, because Laplace of integration is 1 upon S, I of S plus R2 I of S is equal to V I of S. Okay, let's take common I of S here. So when we take I of S common, what is inside? R1 plus 1 upon SC plus R2 is equal to V I of S. This is equation number 1. Okay, let's apply KVL at output loop, second loop. So in the output loop there are two components, one is capacitor and second is R2. Let's apply. Second step, apply KVL at loop 2. Okay, so there are two components, there is one is capacitor, second one is resistor, equal to V of t, or the voltage drop across capacitor. In KVL it will be 1 upon C integration of I of t dt, right? Plus voltage drop across resistance is R I of t is equal to V of t, right? Let's take Laplace both sides. Okay, so it becomes SC I of S plus R I upon S is equal to V of S. Okay, let's take common. What is the common here? I of S is common, so I of S we are taking common here. So 1 upon SC plus R is equal to VO of S. Okay, this is equation number 2. See, equation number 2 V of S, equation number 1 V of S. Let's divide equation number 2 by 1. So equation number 2 divided by equation number 1. Okay, we are taking division here. So the equation number 2, it is a V of S, or the equation number 1, it is a VR of S. So it is a transfer function. Or the V of S here, see, it is I of S in bracket 1 upon SC plus R. Okay, and what is the equation number 1? See, in the equation number 1, I of S R1 plus 1 upon SC plus R2. Okay, I think something is missing here. This is R2, right? This is R2. This is R2, right? So it is R2. Okay, and here R1 plus 1 upon SC plus R2. Again same, I1 of S, I of S and I of S both are cancelled here. Okay, and this is called as a transfer function. VO upon VI is called as a transfer function, right? So what is the remaining here? See, can we take cross multiplication? So it is 1 upon SCR2 divided by SC, right? Whole divided by again getting cross multiplication, so it is SCR1 plus 1 plus SCR2 divided by SC. Again same C, SC and SC get cancelled here, SC and SC get cancelled here. For the remaining 1 plus SCR2 divided by SCR1 plus SCR2 plus 1. This is the remaining here, right? So this is your transfer function. Let's compare with your final answer. What is your final answer in PDF? 1 plus SCR2 and okay, this is exactly perfect. Okay, this is exactly match with your final answer. Just they are putting SC common here, SC common, R1 plus R2 is remaining and everything is same here. So it is exactly match with your final answer. Let's move on the next example, example number 4 from your homework. So example number 4 is two resistor, two capacitor, and this is the output side, right? This is the output side, right? So this is the input side, we call as a Vi of t. This is the output side, we call as a V of t, right? This is the R1, C1, C2 and R2. Okay. See, in such example we can't take loop equation. That's why we are considering here KCL, Kirchhoff's current law. See, we are considering current from this side, this loop we consider current as a I1. From here we consider current as a I2, right? Again from here we consider current as a I3. Okay. See, I1 and I2 is combined here. See, I1 is come from this side, I2 is come from this side, and again is combined here, right? Let's start. See, this is a point where we consider as a node A, where voltage across A is a V0 of t, because there is a no component in this branch, so A voltage across A is a V of t, right? Let's apply KCL at node A. Okay, what is the KCL? KCL is the Kirchhoff's current law, where we are taking current when current is incoming current we take as a positive, outgoing current we take as a negative. See, for node A, I1 is the incoming current here, I2 is the incoming current here, and I3 is the outgoing current here. See, I1 is from branch R1, I2 is from branch C1, both are combined here and it comes towards the node A, and I3 is outgoing current flows from C2 and R2. Okay, so according to our convention, incoming current we take as a positive, so I1 as a positive plus I2 as a positive is equal to, or we take as a minus I3 as a negative. Why? Because it is outgoing current, right? Now it is minus, when we shift at the other side it become plus, so I1 plus I2 equal to I3. Okay, let's convert this current into the voltage form. So what the current is nothing but what? V upon R, right? Let's convert this. I1 means is a Vi of t minus Vo of t divided by what the branch R1, right? Plus what is the I2? This is the Vi of t plus Vo of minus Vo of t divided by branch. What is the branch? Capacitor. What is the capacitor? Is the 1 upon SC, right? Is equal to I3. What is the I3? Vo of t minus 0 divided by, there are two branches in series, right? So it becomes R2 plus 1 upon SC. See, maybe you confused for capacitor. Why we write down here SC, 1 upon SC? As we know, voltage drop across capacitor is the 1 upon SC, right? and here both are in series, so capacitor and resistor both are in series. That's why I write down here R1 plus 1 upon SC. This is the 1 upon SC, right? Okay, let's separate divide to each term. So R1 will separate divide, so VI of t divided by R1 minus VO of t divided by R1 plus VI of t divided by 1 upon SC minus VO of t divided by 1 upon SC, right, is equal to VO of t divided by R2 plus 1 upon SC. Okay, let's take VI common. So which are the VI terms? See, VI terms are, this is the VI terms, this is the VI terms. Okay, so let's put VI common here. VI of t we are taking common. For the inside 1 upon R1 plus 1 upon SC, right? Let's take VO common. Okay, let's put VO. First of all, this VO term we put this RHS side. So shift this VO term towards the RHS side, shift this VO term towards the RHS side. So see, both are minus, so it becomes plus. So VO of t divided by R2 plus 1 upon SC plus VO of t divided by R1 plus VO of t divided by 1 upon SC. Let's take VO common from both the terms, all three terms. So when we take VO of t common, what is the inside? 1 upon R2 plus 1 upon SC plus 1 upon R1 plus 1 upon SC. Okay. So this term is as it is. We have t as it is. Inside the bracket there is a 1 upon R1 plus 1 upon SC, right? VO of t as it is inside the bracket. Put the remaining. Okay, let's put as it is. Let's say cross multiplication, so it becomes SC upon R2 plus. Okay, one second. When we take cross multiplication, it is as it is only. Okay, let's take all calculation in the next. Once again, I want next page. Okay. Okay. See here, VI of t as it is. I think it is VI of S. It is the VI of S because we're taking Laplace here, right? So all t become S, t become S, t become S, all t become S, all t become S, all t become S. Okay, let's solve it. See, when we cross multiply this, so 1 upon R1 as it is, right, plus, so see, division of division, that means there is a SC upon 1, so not S1 upon 1 is equal to V of S. Okay, let's calculate this. So here, see, 1 upon SC, right, so cross multiply this, so it becomes 1 upon SC R2 plus 1 divided by SC, right, plus 1 upon R1 as it is. See, 1 upon SC, so it becomes SC, right? Now, then we take cross multiplication here, so we have S, so it becomes 1 plus SC R1 divided by R1, right? Now V of S, let's take, so division of division, that means it is a SC divided by SC R2 plus 1 plus 1 upon R1 plus SC. Now see, what to do, we are taking VO upon VI, right? See, so this VI we divide here and this whole bracket is divide here, right? So what is the equation become? So when we shift here, so it becomes VO upon S divided by, so it becomes VO upon VI of S, right? And here the bracket, S C R1 divided by R1 as it is, right? And when we divide this term, okay, so this is the bracket where it divided, so it is like this: SC divided by SCR2 plus 1 plus 1 upon R1 plus SC. Okay, so this is, you get the answer. Okay, this is called as a transfer function. Okay, let's take some space here. So this is nothing but your transfer function, right? Can we reduce this equation somehow? How to reduce this? See, uh, what to do? See, numerator is as it is, SC R1 divided by R1, right? I can see what to do. Can we take cross multiplication? So what to do? We are multiplying the. It is very difficult to reduce. Better way, put as it is only. Put as it is only. It is very difficult to reduce, right? Better put as it is. So this is your final answer. Okay. One more example is there. The circuit diagram is like this. Op-amp is there. Maybe you confused little bit there because of the op-amp is there, right? The example is like this. See, suppose they are giving capacitor with one resistor. I think it's the op-amp. Op-amp is the operation amplifier, right? Minus, plus. Okay. Again, there are two components. One is capacitor and one is resistor. Okay. And both are connected with the output, right? Output is V of S, input is Vi of S. Okay, they are already giving this 1 upon SC. This is R. This is 1 upon SC. This is R1. Okay. For that, what to do? See, again we are considering that, as we know, op-amp having two terminals, and this is your node A. Okay, and voltage across this node A is 0. Voltage across node is 0. Okay, apply KCL at node A. Maybe you confuse here. Better than giving explanation, little bit explanation. See, we are considering this current I1. From this current, we consider this is the I2 and this is I3. Okay, so there are three currents, right? Incoming current we called as a positive, so I1 is incoming current, minus I2 is outgoing current, minus I3 is outgoing current, equal to 0, right? Or we can put I1 is equal to I2 plus I3. Let's convert current into the voltage form. What is the current I1? I1 is become initial voltage minus final voltage. So initial voltage is Vi of S minus final voltage at node A. What is the voltage across node A? 0, right? So it is 0 divided by resistor. What is the resistor here? What are the components? 1 upon SC plus R is equal to, what about I2? I2 means initial voltage minus final voltage. Initial voltage is 0 minus final voltage is VO of S. See, initial voltage is 0 here. See, this is 0. Final voltage is VO of S divided by, what is the component across I2? 1 upon SC plus, what about I3? Initial voltage is 0. Final voltage is VO of S divided by, what is the component? R. We call it the R1, right? Let's solve this. So Vi of S as it is divided by 1 upon SC plus R is equal to 0, not as we write down. So minus VO of S divided by 1 upon SC minus VO of S divided by R1. Okay, let's take common. VO we can put outside. So this is VO of S we can put outside. What is the inside? Minus 1 upon SC minus 1 upon R1, right? Because we are taking V of S common, right? And this V of S as it is divided by 1 upon SC plus R, right? Now see, can we take this V of S at the division side, that is V upon VS, which become transfer function, and this multiplication we gives here at the division side, right? See, we put V of S as it is and it become Vi of S, right? Now this is multiplication here, it is divide, it become divide here. So 1 upon SC plus R into 1 upon minus 1 upon minus 1 upon SC minus 1 upon R. Okay, so this is you get, so this is become transfer function now. Okay, let's move on the next page. Okay, this become transfer function now. Let's solve this. See, when we take cross multiplication, so it become 1 plus SCR divided by SC, right? This is your first bracket. What about second bracket? Second bracket, 1 upon C, 1 upon SC, that means there is a minus SC minus 1 upon R1. Okay, so division of division, so become multiplication, right? Now let's put SC at the numerator, so SC divided by 1 plus SCR, right? Second bracket, see, when we take cross multiplication, so it become R1, right? So it is minus SCR1 minus 1 upon R1, right? This is your transfer function. Let's take cross multiplication. One second, this is 1 upon R1, right? Let's put R1 at the numerator. Okay, so it is SC divided by 1 plus SCR. This is first bracket, right? Second bracket, R1 we put at the numerator minus SCR1 minus 1. So this is your transfer function. Okay, can we do anything here? We can't do anything, right? So it is as it is. Okay, so this is your transfer function. So such a type of example may be asked in your final exam. Okay, SCR1. Okay, this is as it is, right? See, we are just multiplying with the numerator and numerator. When we take multiplication, numerator with the numerator and denominator with the denominator, what's happen? So it becomes SCR1 divided by 1 plus SCR and minus, and we put outside, it becomes SCR1 plus 1. Okay, so this is your final answer, right? Again, if you have any question from transfer function, please send me photo of that example. I will give you solution. Okay, thank you.